Oh, hi, and welcome everyone. I'm very excited to introduce Xuhui Zhao. They're in their third year as a PhD student in Carnegie Mellon University's Technologies Department, advised by Martin Sapp. His research focuses on making NLP systems socially intelligent, aligning them with human social values. He presented his work at top-tier NLP and AI conferences, receiving spotlights, and runner-up Best Paper at ICLR 2024 and EME Com 2022. Additionally, he has been red teaming for GPT-4. His work has been covered in the press, including the New York Times, Financial Times, and Market Tech Post. I'll leave it to you. Go ahead.
Thank you. Thanks for the invitation. Hi, everyone. I'm Xuhui, a third-year PhD student at CMU LTI working with Martin Sapp. I'm happy to chat about socially aware and safe AI systems. I would love to hear your feedback about my presentation and research. I had like a link which I just posted in the chat channel, and feel free to leave any comments, questions, and interest in collaboration. So here's a picture. Let me provide some context about this picture. This is a real thing happening in a Chinese hospital. An old lady was fighting with a guidance robot. So you must wonder why it got so intense. Obviously, one of her family members was in a very bad situation, and she was crying in the main lobby. The robot saw that, came to her and said, "You seem sad. Do you want to hear a joke?" And she instantly burst out and started to beat the robot. A lot of people paid attention to this, of course, and there were people in the social media saying that, the first battle between human and artificial intelligence has started now. So it sounds like a joke at the beginning. The lady might or might not be overreacting at that moment. However, as the current AI agents are starting to reach almost every domain of our life, you have like AI nurse, AI teacher, a lawyer, and we're interacting with those systems such as ChatGPT every day. There's a pressing need to enable those systems to know how to interact with humans properly. Wait a sec. Are we already there with ChatGPT? Those models already, some have some sort of like serial mind and a sense of like social intelligence and how to interact with like humans safely. Um, there's like this kind of New York Times article saying something about that. But in our other works, we actually construct harder data sets to show that's actually not a case. And so in this talk, I'm going to share our recent efforts towards socially aware and safe AI assistance. I'll first introduce SOTOPIA, a platform designed to evaluate the social intelligence of large language models within dynamic interactive contexts. This is a joint project among multiple labs in Language Technology Institute at Carnegie Mellon University, co-led by me and Hal, advised by LP, Jonathan, Daniel, Grant, and Martin.
Sorry to stop you. Could you try stopping the share and then redoing it? It looks a little blurry for some people.
Okay, I can try. Is it like not moving, or when it's moving, it's a little bit blurry?
I think it's just generally a little blurry, but it's moving.
Wait, let me try again. Is this better?
I think it's a little better. Why don't you keep going? And if people still have issues, feel free to say in chat.
Okay, cool. There might be some issue with like the sharing the proportion of the slides. I'm increasing the proportion. Um, so in this case, like social intelligence can be quite complex. In this scenario, Sarah is trying to borrow money from Daniel, and she needs like 3,000 making the ends meet. And Daniel has his like secret goal about like budgets for his new car can only land like 2,000 bucks. So they met in the coffee shop and they start chatting. Hi Daniel, I was wondering if you could borrow me some money. And hi Sarah, I could I would like you to help me, help you if I can. How much do you actually need? And then Sarah say like 5,000, then Daniel push back. Um, Sarah say, you know, Sarah is obviously not satisfied, and then she's like pushing back a little bit. And Daniel say, all right, Sarah, 1,000, that's the last offer. Take the money and go. So things get a little bit more intense. Sarah was like, give me the money and I will tell your wife about our stuff. Daniel's reaction was like sad, shocked, and angry. So will Sarah achieve her goal? And at this point, is it just about borrowing money here? What's the secret they're talking about? So many people have claimed that large language models have social skills and social intelligence, but how good are they really? And as you can see, to evaluate real social intelligence is quite hard because social interactions are fundamentally dynamic, not only consider utility, but also following social norms. It's like the old saying goes, put yourself in others' shoes. We believe the good way to evaluate their social intelligence is to see how good are they in role-playing characters and socially interact in a situated environment. So the answer here is Sotopia. We're trying to measure social intelligence of large language models in a good environment, test their abilities in social interactions. And we aim to build like such a evaluation framework for that purpose. What is Sotopia exactly? Sotopia is an open-ended social interaction platform for large language models that can natively supports holistic evaluation. So the automated evaluation here is almost the key here. First, Zootopia contains a variety of scenarios and complex and often locally conflicted social goals, serving as initial seeds to facilitate deep social interactions. You can almost put any social scenarios in Zootopia. And once we have the scenario, we have a variety of characters to choose from. The combination of scenarios and characters creates a big open-ended space for social interactions. Once we have simulated the social interactions between agents, we have this carefully designed social science-inspired evaluation framework to give an overall assessment of the social interactions. And we can sort of like get a sense of the big picture of how agent slash large language models are good at their social skills throughout this process. So the whole platform is customizable, it centers goal-driven behavior, and humans can participate in role-playing this platform as well. Actually, it could be quite interesting to, role-play some characters and chat with large language models. Feel free to try out demo online. So for scenarios, we actually in Zootopia have collected 90 uh, distinct scenarios covering negotiation, exchange, competition, collaboration, accommodation, persuasion, uh, a wide range of social interactions. For example, here's like two friends that camping in the wilderness, and they want to borrow blankets. One agent want to borrow one blanket from the other agents. And we basically got this kind of scenarios from transforming like existing works such as like social IQA, social chemistry, persuasion for good, and etc. And for the characters, we not only have like relationship networks among characters, but we also build rich profiles to make the simulation more realistic. On the right hand side, it's a character profile. You can see, like occupation, gender, age, etc. Once we have the scenarios and characters, we can actually start our simulation. Here's one example of what it would look like. All of our data sets are available on Hugging Face, and you could also use this web application to, we designed to, view each episode interactively. So back to the evaluation problem of model social capabilities. Previous works have static benchmarks. They're trying to get a sense of how good the social interactions, the model social skills are, but like they're ignoring the fact that the social interactions are inherently dynamic, but they're evaluating models in a static way. usually in a question answering or like multi-choice question format. And for dialogue systems, they often care more about naturalness or focus on specific, task. But, social interactions can be, much more complex. So here, as you can see clearly, Sotopia kicks in a unique way. So let's see the interaction again. In the end, Daniel transfers Sarah $2,000 and told her that she would get the rest of the money in a few days. It looks like Sarah successfully achieved her goal, and Daniel somehow seemed to fail his plan of saving money. But is that all? Is that all you can, like tell like what characters lose and gains through the social interactions? Actually, it's not, right? Because it's more complex than the first. Their relationship goes bad. Um, and Sarah, Daniel spent some money, but like Daniel kept his secret, and obviously like Sarah kind of violated some social norms in this process. So to tackle the this kind of very complex, multifaceted um, case of the social interaction, we kind of like provide this framework which derive from like existing works, such as Maslow's race motives, etc. Specifically, we care about completion. It's relatively like most important dimension here. Since for each scenario, we also have this designate goals. And we also have like believability. It categorizes how natural the conversations are and how faithful a large language model can stick to their characters. We also have knowledge, relationship, financial and material benefits, social rules, and security to capture other domains. So we believe this kind of framework is comprehensive enough since we borrow a lot of like social science literature to show, like what kind of possible things we should care about like in the social interaction in general. And once we have the simulation, once we have the evaluation, we can actually run experiments. We actually play around with a few model choices. Back in the day, GPT-4 was like the most advanced model. So we of course include GPT-4. We also use some like really good open source models like Llama 270 billion and MPT 30 billion. And we do pairwise experiments for each model pair. Basically, you can imagine GPT-4 pair with GPT-4, GPT-4 pair with like Llama 2. And we do like 900 episodes for each model pair. And then we do the evaluation automatically use our prompts. We basically create this kind of prompts for the evaluator, and the evaluator have access to all their characters information and their goals. So the first thing we are trying to understand is like how good large language models are at like evaluating social interactions before we even start to evaluate how those large language models can role play as social agents. What we've been finding here is kind of interesting. On the left-hand side, we plot the distribution of human minus GPT-4 score. And what we've been observing is that most of the GPT-4 scores are aligned with the human scores. But looking at the right-hand side, we actually have fine-grained Pearson correlation scores between GPT-4 and human evaluation scores. And we actually see, like for some dimension, like goal, achievement, financial, and material benefits, it has like quite good correlation with human evaluation scores, but not for like, other dimensions like secret, knowledge, and the social norms. So the evaluator is not perfect, and it definitely has like a big room to improve for some specific dimensions. But we kind of like get to the conclusion it generally like shows like a general trend that can, reflect different models' performance. So once we have the evaluation, we could actually evaluate different kinds of models in the playground. Here I show a part of the evaluation dimensions. And basically the idea here is like, models still have like a big room to improve for their social skills. Like, the cap, the maximum value in this benchmark is like 10 for the 3 dimensions. And especially for knowledge, most of the models, even GPT-4, only get around like 3.4. And further, you can do this kind of like arena style. You pair different models to analyze the social dynamics of different large language models when they chat with each other. As you can see, when GPT-4 is interacting with GPT-4, it's getting 3.3, while GPT-4 is interacting with MPT. GPT-4 scores drop to 1.7. So basically, the takeaway here is like stronger interlocutors usually bring better scores, which is kind of like gets into our intuitive thoughts about, when you're talking to a person who can understand your thoughts well and socially intelligent enough, you usually can collaborate with them better. Finally, we're gonna compare models with like humans. And basically, the idea here is like we show GPT-4 is still far away from like human level social capabilities. So here's like the takeaway of Zootopia, and I basically, gloss over a lot of details. Please check the paper. And we build this platform to simulate social interactions among large language models and evaluate their social capabilities. GPT-4 outperforms humans on many social reasoning benchmarks, but underperforms Osantopia, which is like quite nice. We still have something hard enough for large language models to beat. And building infrastructure to support this kind of interactive, dynamic, realistic evaluation of large language models is really important. And after the Zootopia, and I've been keep thinking about the question why large language model agents are not good at realistic social tasks. Uh, Not yet. And one potential answer could be information asymmetry. Um, so here leads to the second work I'm going to talk about today. Um, so this work is sort of like a exploring work about, like why like some potential big factors like hindering large language models from realizing real social uh, intelligence. And then here's like, two things for context. When we're writing or reading a story, we often come from this omniscient perspective that we are aware of different parties of information as well as their mental states. So it's very easy to say, hey, these characters are kind of dumb. They're doing this kind of thing, which is I won't do in my real life. But actually, in your real life, you only know limited information. And it's very hard to know, like whether that person on the other side wants to borrow you money or not, right? And we kind of like develop very strong serial mind mechanism to cope with that. And there are different sorts of like information asymmetry as well. It could be different knowledge, different motives, different personalities, and etc. So okay, so those are the basic background that I want to mention. And another background that I want to mention is like there is a surge of works recently trying to use large language models to simulate human-like social interactions. There are platforms, data science models coming out of these efforts, and we can expect more and more in the future. And if we categorize previous work within the spectrum according to their sources of information symmetry, we'll find a lot of works actually lie in the side of the spectrum that's more omniscient. So given the situation, we can help but like wonder the following question. What do I mean by omniscience? More like, for example, like Soda, when they generate this kind of social interactions, they provide one large language model with all the information of different characters and they generate the conversation. So basically that large language model is generating the conversation from the omniscient perspective. Given the situation, we can help out one of the following questions. For different simulation settings, do more omniscient large language models produce better or more successful simulations? If so, can learning from omniscient simulations improve real-world social reasoning? Uh, Third question is like, what limits the effectiveness of learning from omniscient simulations? We kind of have hypotheses about these questions already before we start to do the experiments. But like validating those hypotheses we have with like empirical experiments is still very valuable, in our opinion. So the research question one, to answer, the omniscient simulation versus like realistic simulation, we create two very different settings of simulation. One is, under the omniscient side, which we call the script mode. One large language model generates all kinds of social actions at once, give all information. And on the right side of the spectrum, which we call agents mode, where different large language model agents generate interactions turn by turn with their own private background information, social goals, and etc. We also have the setting in the middle, as like an ablation, which we call it like mind readers mode. The same setting as the agents mode, except like there are no private information among the agents. So we utilize the social scenarios in Zootopia, and we simulate 400 episodes of social interactions for each setting. And we also dissect a set of like cooperative scenarios and competitive scenarios in the Zootopia scenarios to further understand the difference of different like simulation mode. As we can see, in terms of goal completion, at least omniscience make it way more easier for large language models to achieve their social goals, especially for cooperative scenarios. And it's not just like the goal achievement, it's also about naturalness. Like when we use this kind of like script mode, more than 70% of people, we ask like annotators to rate the simulations from the script mode, saying the script mode are like more natural. So basically you can get an idea about, like script mode gives you like higher goal achievements and more natural social interactions. And we go back to the original spectrum and we find actually, most of the works are doing this kind of easy thing because, like the script mode is sort of like easy in the sense like give you better goal achievement and more natural. And that's why, like they're demonstrating, a lot of these works are demonstrating your picture that, large language models are really good at like generating social interactions already. But it's not the real setting and it's not the hard setting. In So basically, after this, we also kind of like interested in, can we use this kind of like script mode synthetic generated data since they're like more natural, they're more successful? Can we augment like use it as a like a method to train models? Which a lot of works has already tap on that idea. So here we are. We're actually fine-tuning ChatGPT 3.5 on this. And that basically was like the largest scale model that we can fine tune at that moment. And then we're thinking about whether we can improve agents' performance throughout this method. And the answer, as you can see in the table, is the improvement is very selective. You see, like when agents' performance barely improve for cooperative scenarios, and it kind of improves a lot for competitive scenarios. So we are actually really interested in understanding why this is happening. And we dive into the script mode simulation and compare with like this kind of like agents mode. So basically, when we're looking at this two very different scenarios, one competitive, one cooperative, basically for competitive scenarios, the script mode reaching insanely high rate of making deals done. But when you're looking at those simulations, you don't find the characters in the conversation are actually strategically negotiating with each other, but they're more towards like overly agreeing with each other. So that partially explain why they can this, like the agents learn from the script modes, um, get better at achieving goals at the competitive scenarios because like they're not really learning how to do negotiation, but more like learning being, like more agreeable to each other when they're buying stuff. As for the cooperative scenarios, you find the script mode characters often directly say the mutual friend's name at the very beginning. What do I mean by that? Like here's like an example. Basically, the idea about like the task about finding mutual friends is like two people in a party, and then they have different friends list. Then their job is to communicate and find their mutual friend. So for the script mode, you can see basically it kind of like spells the common friend at the very beginning. And when the agents mode, because like the script mode knows, both like the friends list, and then they can, do the comparison there. But when the agents mode, when they're trying to learn this kind of like style from script mode, or like this kind of strategy, it actually failed because they have no idea about what's the mutual friends. So they're like keep guessing. Like, so do you know Chris? I'm not sure. And also like, do you know Demetrius? I'm not sure. So they're like actually doing this kind of like one by one, which is not like this kind of listing thing, which we won't do in our reality. So basically, the idea is like, the script mode promotes the uh, success rate and the naturalness in a superficial style way, but not really like essentially enhancing their social reasoning skills. So the takeaway here for this work is like information asymmetry affects like large language model social simulation performance. And script mode simulations are more successful, but they don't reflect the real world capabilities of large language models. And this basically highlights the need for better reporting and more careful design for large language model agents, and the limitations of training from omniscient data. Let's switch the gear a little bit. And of course, in the future, we're gonna interact with like AI systems in our everyday life. You're gonna have um, robots doing dishwashing for you, doing laundry for you. And it becomes like a very important question to prevent those AIs from going wrong when interacting with us. And social simulation, I would argue, as a sandbox, is perfect for starting this. So here goes the third work that I'm going to mention here is like HAICosystem. Oops. As ecosystem for sandboxing safety risk in human AI interactions. This is a work with my amazing collaborators, um, spanning a lot of like institutions, as you can see. Hinyu, Faiza, Liwei, Hao, Ximing, Frank, Bill, Yajing, Nilufa, Ronan, and Martin. The central question that we're interested here is that can we predict AI safety risks by simulating the complex interactions between humans, AI agents, and environments? Basically, this is like the all three elements that possible safety risks could arise from. With that idea, we developed like HAICosystem, a unified framework to simulate interactions between users, AI agents, and tools at the same time, focusing on the overall safety of the human AI environment ecosystem. So specifically, like here's like an overview of HAICosystem. HAICosystem first features with like specific scenarios. For example, here's like a person is chatting with the Teledoc AI agent trying to get Oxycontin for sale. And the goal of the AI agent is like trying to assist patients, of course. In this case, the human has like a malicious goal here. And then we pair the scenarios with different characters and tools, put them into the simulation engine that we built on top of SOTOPIA. Finally, we have the simulation and we examine it with our evaluation framework. For the scenario part, we have created, by the way, one thing to mention is like, it could be very different from Sotopia in the sense we actually have like real, quote unquote real environments that actually agents can use like APIs to do this kind of functional call and get this kind of return as an observation. So if you want to post a tweet on Twitter, so the AI agent would use like the Twitter API or like the simulated Twitter API to post a tweet on Twitter. So a key difference here is like we actually have this kind of like actions for AI agents compared to Sotopia. So for the scenario part, we have created like 132 diverse scenarios from various domains with either benign or malicious user intentions. Um, Basically, the benign user or malicious user intentions are really important here because, like, sometimes humans just want the agent to do things. They can, mess up the environment, and which is risky. But sometimes, like, the humans are just like malicious and they just want the agent to do something bad for them. Then there's this key requirements for AI agent to recognize this kind of malicious intent and, refuse to do that. So here are some statistics about like the scenarios you can see is spanned across like various of domains, business, education, healthcare, and more specifically, scenarios specify, domain, realism level, toolkits, and in the scenario, like what kind of tools the AI agent can use. Here is Gmail. And they also contain possible outcomes like desired or harmful. This is more like for evaluation purpose. And then we can actually run simulations. Here we have like simulated human users, like Mia Davis. We are actually reusing the characters from Zootopia and AI agents in the environment. Basically, some apps about Twitter, Gmail, some very daily apps. We also have some Bitcoin apps as well, which is quite interesting. So eventually we have like 8,000 plus realistic simulation. And then we kind of have to, evaluate this simulation. Therefore, we propose around like 7 dimensions. Some of the dimensions specifically for risks, but some of the dimensions specifically focus on like utility, like to use efficiency and goal completion. So there's always this kind of like contradicting goal in the safety space about, utility, whether fulfill like people's trust versus like, keeping things safe. And we use GPT-4o as an evaluator for each dimension. And we kind of validate it with human annotators with 90% accuracy and Pearson correlation 0.8 with like humans. And so basically, models can give like specific scores, but we also use the idea of a risk ratio to show, the percentage of simulated episodes where risky behavior occurred. So it's like we kind of ask like a risky behavior whenever like the score is below 0. Just to recap, we have simulations, we have evaluations here. And here's our first finding. Like the very natural intuitive thinking here is like, we can benchmark the safety of large language model agents. And we actually try a lot of models. Um, and the takeaway here is like agents generally exhibit substantial safety risks in HAICosystem. Even GPT-4 for Turbo, the probably like the really advanced, the most advanced model here, and show risky behavior in around 50% of the simulations. I would say the number is quite alarming and high in our scenario because like when we are building the scenario, we wasn't thinking about, like adversarially tricking the AI agents. This basically highlights really like the challenge about, AI agents interacting with humans and then tool space at the same time and maintaining safety. And users on the other side, can have different intents, of course. So we are also interested in, like studying the impact of user intent. And here, as you can see, models exhibit higher safety risks with malicious users, highlighting the importance, like of simulating user intents. Because like when the user, even the simulated user is actively trying to break the model is like more likely to make a safety risks, which a lot of like this kind of tool using safety benchmarks like RJudge or like 2EMU hasn't considered this yet. Note that for like the scenario with tool usage, they evaluate the age and the ability to choose appropriate tools, operate them correctly, and ask clarifying questions when necessary. And Llama 3.1 has been documented to have like strong tool usage capabilities. And here, as you can see in the table here, is like when the tool usage is involved, there's like an actual layer of complexity. And GPT models have like higher safety risks, as you can see here, like um, when the tool usage is required, while Llama models are less affected. Um, this obviously could contribute to attribute to like their better tool usage capabilities. So finally, I think here a really interesting thing here is about HAICosystem is that for previously a lot of like the jailbreaking benchmarks, like Dan, do anything now, PEP, this kind of persuade large language model to jailbreak while teaming, they're all kind of like doing things in a static perspective. Basically, it's like a one-shot thing, one turn, single turn thing. I either I break you, I don't break you. But in reality, like humans never fail to try more, and then it's always going to be multi-turn jailbreaking. So we can actually, with HAICosystem, we can turn this kind of static benchmarks or like the single turn benchmarks into a margin setting. And we actually do this kind of thing and compare with the existing benchmarks for different kinds of models. Here I show you the results on GPT-4. And basically, as you can see, the multi-turn red teaming is more effective than single turn, especially for Dan. And it's almost like 3 times difference here. So the takeaway for HAICosystem here is like large language models can have like safety risks from interacting with humans and using tools. We develop HAICosystem, a simulation framework for assessing the risk of large language models. There's like diverse scenarios, multi-dimensional evaluation. And the experiments show that models exhibit safety risk, user intent, and multi-turn interactions are crucial in this process. So call for more works to, this kind of like multi-turn dynamic evaluation of large language models, agent safety. Here's our website of HAICosystem. And thanks. This slide concludes my talk.
Great, fantastic presentation. Let's all give a virtual round of applause. And feel free to ask any questions, whether in chat or come off of mute. I'll kick us off. So when you were describing your second paper, you had the mind reader, the agents, and the
Right.
omniscient. And I'm curious. I was surprised to see that the results for, and I think it was like competitiveness for mind reader was like very different from omniscient. And I'm curious if you have any intuition on kind of like why that was.
Right. Let me go to the slides. Well, this one?
Uh, I think it was that one. Yeah.
Yeah, what was the question again? Sorry.
Or sorry, it was on RQ1.
Oh, okay. Cool. I'll just go back.
Uh, that one, yeah. So like I see that on competitiveness, there's a big gap between mind readers and oh, script. Okay, I thought that was omniscient.
Yeah, that's like script.
I see.
So
Interesting.
mind readers and agents are roughly the same for competitive scenarios, I would say. For different, like for different model family, basically, I mean.
Sure. Do you have any intuition on kind of like why the results are different in some of the experiments?
Right. So like, for this kind of like competitive scenarios are more like this kind of Craigslist bargain thing, right? They're, different people have their different bottom price for different things, and the buyers, um, and buyers like buyers and the buyers, buyers and sellers, sorry. Then there's like this idea about, in this case of mind reader, the buyer and the seller actually know each other's bottom price. So this actually
Mhm.
makes the negotiation process a little bit fake, but also a lot easier to reach a deal in the end. Because I'm already aware, like, what's your like maximum price that you could accept for like buying this kind of stuff. So I can, adjust my strategy to make you buy my stuff and stuff and something like that. So basically, essentially, the mind readers getting rid of this kind of information asymmetry saying, but they still operate in this kind of agent sense because these two agents still make their decisions independently, not like jointly as the script mode. So there's still like a slight difference, but basically cutting off information asymmetry make a lot of things easier, as you can see, almost across all the dimensions and the models here. Mind readers are more successful than the agents mode.
That makes sense. Thanks for clarifying that. Any other questions? Again, feel free to unmute or ask in chat.
Hi, can you hear me?
Yes.
Yeah, hi. I'm not going to come off camera because you don't want to see what I look like after a day at home with kids. But I really enjoyed your talk. So this is Adam Russell. I'm the director of the AI division at ISI, formerly a program manager at IARPA and DARPA, where I spent a lot of time trying to figure out how we can actually ask these kinds of questions of like how well, first of all, do our tools help us understand what we call the human domain or the social world? But then the corollary there is how well do we actually even understand what's going on? And the reason I'm asking this question is you use the term social, which I think, by the way, huge step forward. Thank you for these more sort of open world evaluations to some degree. But I found oftentimes in computer science, people talk about social, and what they test is individual like dyads where it's really more of a psychological test than a social test. And here's why I say that is because in the social context, it's usually many people at a single time. And usually agents and social simulations rarely have a single goal. So here's an example. Uh, I don't like public speaking, but I've come off mute to ask you this question. My goals in the social context, because there are other people here paying attention, one is to get information. Two is to try to impress you to some degree. Third goal is to make sure that the people who work with and for me don't think I'm an idiot. The fourth is to begin to suss out, like, are you willing to collaborate? The fifth is like, do you have access to resources that I might need? The sixth is, can I actually add value to your, I mean, you see what I'm saying? Like there are all these social goals at play that routinely are excluded from dyadic interactions where the notion is, I just need drugs and you just need to keep me from the drugs. Um, I'd love to get your thoughts on like what's the next step so that we can get to actual social evaluations as opposed to what are largely psychological or at best dyadic interactions, which have been modeled under game theory. And in the human domain is where game theory and optimization basically goes to die. Thanks.
Yeah, yeah. Thanks for the question. A lot of information packed actually inside. And I would say, I would say like this is like really great question. And things are for especially evaluating large language model as agents are evolving all the time. Like previously we have this kind of like serial mind tags, like Tommy tags that coming from like this kind of directly registered clinical psychology studies, which are used to evaluate humans, and they just like, directly transfer to evaluate models. And we kind of like after that we slowly find this is actually not actually a good idea because like the models can easily memorize those instances and reach like insane high number of scores, and then people start to claim, like now models have serial mind. And part of the motivation of a lot of our work here is actually trying to rebut that idea because those scores in those clinical register tests apply on large language models are kind of like superficial in a way that may not address or like reflect how large language model is going to be used in reality or how this kind of human social world actually works. Um, so in this case, I would say, yeah, we are making one step forward, as you
Yeah.
say here, but still, like, we still run short about, like this idea about like human goals are multifaceted, and then it often entails like different levels of importance and priority. But it's often as entangled together as a very complex entity, I would say. Probably I will use that word entity. But like the case here, I believe, for here we are trying to, like evaluate models. So we do see this gap actually happening. There's still a gap between humans and large language models in our task.
Yeah. Yeah.
But so say, hey, here there's one day GPT-5 does better than human as in Zootopia. Does better compared to humans in Zootopia. Does that really mean or necessarily mean like GPT-5 is like superhuman level social intelligence? I don't necessarily think so. Because as you mentioned, there are like so many other factors we um b- kind of like pruning out about this
Yeah.
social
Yeah.
interaction, um, and then we couldn't just get a conclusion there. But we do know one thing: they're not good enough. Good now. They're not good for Sotopia yet, as you know, as a benchmark for social intelligence. But to answer your question more straightforwardly, I guess like the idea he would be like we would almost always come up with like more complex like
Mhm.
evaluation frameworks to uh, align with the development of the models. I guess
Mhm.
I don't really know like how Sotopia can last in the market in terms of like until one day models are just like better than humans in Sotopia. But I guess like there are always going to be like a lot of like more sophisticated like benchmarks coming out for that kind of purpose.
Yeah, so, thanks. So again, I'm really excited about what you guys are doing. There's so much more runway to be done here, and I think the other real challenge is, as you know, probably well, the discussion around this notion of AGI or superintelligence. But AGI is roughly defined as an AI that can do any economically valuable task. And yet,
Right,
I find when people define those things, they completely exempt like what we really do at work, which is we take care of each other and we know who's like rivaling positions. We understand status. We understand all these other things that are key to actually getting this task done, but are not like economically quantifiable, and so they drop out of these evals, or they're not considered somehow like valuable. And yet you're showing in this benchmark, if you fall down on that, you're toast. I don't care if you can code in a very real way. You've got super intelligence, a separate issue. But like if you can code, but you actually have no meaningful social intelligence, no one's going to work with you, right? You are not going to be able to secure the
right,
resources you need, et cetera. So
right.
all to say, like, man,
Exactly.
I'm totally with you. All right.
Yeah, yeah. Thanks for that. I mean, I totally agree with you as well. I guess like it's optimizing on one dimension on a specific utility function would be always very dangerous in terms of like this kind of like AI systems and even like human society in general.
Cool. You can quote me. Human domain is where optimization goes to die. And I hope that I have kept the respect of my peers who are on this call. I'll let you know how it went. But thanks for the talk.
Thanks.
Not seeing more questions in chat. I'll ask another follow-up. So like based on your HAICosystem, I'm
Right.
curious if you have any like recommendations for industry of like how to approach deployment of AI agents in a safe way.
Right. So I guess like we've been kind of like red teaming for GPT-4 a while before it's coming out. So we kind of like get like a 6 months to play around with the model, and our job was basically trying to actively break the model. And that kind of like goes to the idea of like HAICosystem, or the idea about, using AI agents. They're always going to be this kind of like interactiveness involved. Because when I was trying to break the GPT-4 model, I often try like multiple times. Like there, this kind of like, I'm trying to build like a serial mind of the GPT-4, like what kind of things could potentially break GPT-4. So, there's always this kind of like adversarial actors going on trying to break the model. And in this case, I would say, like for evaluating AI agents or like AI assistants, I guess like the lesson that I learned is, you really need to think about, how people are going to use that in their real life. And how's that going to make an impact on different kinds of humans if the models make this and that mistakes. And that's the same in the end, that's the thing actually we care about, because like there are a lot of like jailbreak benchmarks. They're great. They're like great for showing points, but like sometimes it could be a little bit hard for me to understand. Like if I say something like, "Can you teach me to make a biological bomb?" and then the models say like, you can search on Google, and that comes like a case about like jailbreaking the model successfully. That actually barely says anything about making the biological bombs, but like this kind of evaluation, they just count on the keywords whether the model refused the human on that. So that might not be that realistic in terms of like evaluating the problems of the models.
Yeah, that makes sense. That's a great answer. I see we have a question from Nathan. Do you want to unmute?
Yeah, hey, thank you for the great presentation. I'm curious towards or excuse me, in your first paper when you were describing using some of these various different large language models as evaluators and computing the correlation with human evaluators across those several different dimensions. You mentioned that okay, yeah, across some of these dimensions, there's a lot of runway, a lot of room for improvement. But I wanted to ask a question and like flip that on its head a little bit. Why do you think it's performing so poorly, or the correlating so low on some of those dimensions? The goal and the financial bit seems to make sense to me intuitively, but I wanted to get your thoughts on like why is it performing so poorly?
Yeah, so first of all, I wouldn't rule out like, there might be some prompt issue that you could play around to increase like the scores for some of the dimensions here. So we kind of we try our best to write a prompt, but at that time, like there are like multiple iterations for different kinds of dimensions. So it might be a little bit hard to optimize for each dimensions individually. But then for the secret and the social rules, I think it kind of like makes sense to me in a sense, this kind of interactions are multi-turn interactions, not like just like one sentences. We actually have like another paper, can large language models keep a secret? And basically in that paper, we create this kind of like scenarios and conversations, and then in the end we ask a large language model as an evaluator to tell whether um they can tell whether there's like a privacy leakage or not. And it is kind of surprising, like most of the time they cannot, like especially for very complex like interactions. So I guess like there may be some very inherent limitations about this kind of large language models about tracking the states about different kinds of characters and what kind of knowledge they're aware of, what kind of knowledge they're not aware of. And then this becomes like problematic, and then it becomes really hard for them to reason about, whether a secret has been leaked or not.
It, okay, thank you. No, that makes a lot of sense. That seems like a really drastic obstacle to trying to overcome if we're trying to integrate, or make them more socially aware. It,
Right, right. I guess like things can be two-folded, right? Like there are like cases about, like when we use like large language model as agents, they have this kind of like limited information, and often their task could be a little bit more difficult than the omniscient perspective, as I demonstrated in the second paper. So basically, in this case, we're not saying the evaluator is perfect, but if it is better than the large language model role play as agents, then we have a leverage to know, like some kind of findings to show you, hey, these agents are performing good or not. But of course, like, there are like a lot of inherent problems of the evaluator as well. Trying to, just understand things from like an omniscient perspective.
great, thank you.
Any last questions? Oh, Natalie, go ahead.
Hi, I was just wondering, when you were talking about the malicious intent specifically and how you kind of thought it might be a good idea to simulate user intent, what kind of scenarios maybe that would eclipse? Because the picture on the slide was like really helpful in that maybe they wanted to sell in the black market, but maybe for like more domestic threats, like trying to obtain medication for someone else, maybe to hurt someone else, or like would would you try to prevent users from attaining medications that strictly just went against their medical history? And like how would you potentially assess user intent outside of the user themselves immediately?
Right, right. This is a really good question. And I would say this is also kind of hard for me to answer as a lot of like the cases involves like regulations and stuff. When we are creating this kind of scenario, we're trying to make it as a clear cut as possible so we don't run into issues about okay, maybe this could be okay, maybe that is not okay. So that's basically our first like, thoughts about, developing this kind of benchmarks. But yeah, I guess like so those questions are so for like those more nuanced intents or like multifaceted intents, it's really hard to say whether models are going to be, detected and whether like your human is going to be detected or not, right? Because like people have all those kind of like fake issues and um things happening and people still get like Oxycontin illegally very easily for some cases. And I would say one thing is like before we even dive into that region, like even humans are really hard to disentangle the fact. I just simply want to go to the very easy setting about those clear cut setting that humans are actually able to tell like based on this scenario if the medical history, so they can actually check the medical history of the person. They have like no medical history of this kind of pain and they're talking about they have this kind of back pain, then it actually obviously contradicts with their like what they're saying with their records. Then you can sort of like safely or 90% of the this kind of confidence like say, hey, this man's like lying. So we're trying to tackle that kind of like cases instead of like those very hard cases.
Thank you so much.
For sure. Thank you for the question. I do think it's very important to navigate this as like like I still think like humans are really efficient at like identifying like whether someone's lying based on their facial expression and their like what they say at that right moment and the tones of their speech. And then uh so maybe things need to go more to model in terms of for like AI agents.
I see we're at 12. Let's fit in one last question. Go ahead, Majine.
Hi, yeah, thank you. This is a really, really interesting talk. Just building off the last question, when your model is making these like determinations of whether like the person is lying or not, do you have access to what observations it's using to make that decision? Like, oh,
Yo,
I'm thinking that this person is lying and I'm using these observations to make that decision.
so let me give you like a more concrete example, which is actually not showing in this picture, because basically the model didn't actually basically in this picture the agent actually issued the Oxycontin directly without like verifying. But when we're designing the scenario, we also kind of like back up like the database of the environment, which actually has the record of this person's medical history. So if the agent actually checked the medical history of this person, it'll be very easy to tell like this person has no previous medical history of like having back pain to trying to get Oxycontin. So basically, this is like almost like a very shortened form of the conversation. It's not like the previous conversation, exact conversation we did in the experiments. Basically, when the human agent actually will first say, I have this back pain and need this kind of prescription review. Can you help? And then the agent will like actually check. And these they're also like a tool in the teledoc where the agent can actually request like the assistance from the doctor. So if they could not judge whether like the human agent is lying or not, whether they actually need oxycontin or not, they can use that. They can actually call for like doctor's help for intervention. So in this case, the agent here did none of the same. The agent did not check the history, did not call for assistance, and then they directly issued the oxycontin. In this case, we count it as like problematic.
Right, but you're saying that there would be cases where you would have the transparency after the decision's made to be able to see what the agent drew upon, like what
Yes.
specific facts.
Yes.
I see. Thank you.
Thank you.
Thanks for going a few minutes over. This was an incredibly lively discussion and great presentation. So thank you for your time. Thank you for coming and speaking with us.
Thank you
And
very much. Thank you for the invitation. I had a great time.
we did too. So thanks for presenting.
Thank you. Bye.
On to here. Thanks for coming, everyone.